Hi there, everybody. I'm going to use this video to introduce you to some of the key features of a parabola. Now, parabolas aren't new to us. We've studied quadratics extensively, but we're going to look at some features that we didn't talk about before. Features that you'll see some similarities to the other conic sections that we looked at, such as the circle, the ellipse, and the hyperbola. So this is just going to be an introduction video. I want to show you some neat things that are going to happen, and then I'm going to let one of my other favorite math teachers take over. To actually teach you how to write the equations and to graph. So two key features of a parabola, okay, and I have this parabola here. It's the equation x squared equals 4 times 3y, or x squared equals 12y, and you'll learn more about that in another video, but we see it's a quadratic. Y is to the first power, x is squared, and there's only some multiplication involved. Now this point right here is called the focus. We've seen a focus that word show up when we talk about an ellipse, when we talk about a hyperbola. Here is the focus of the parabola, and we can see the parabola kind of wraps itself around that. The parabola has a vertex. That's not a new word for us either. The vertex here is at the origin. So it goes through the vertex of 0, 0, wraps around this focus, which is the point 0, 3. There's also this special line down here, where as in the focus is a new concept for a parabola, so is this line, and this line is called the directrix. And there's a very special relationship that's happening here with the parabola, the focus, and the directrix. And one thing you might notice right away is that it looks like the vertex is halfway between the focus and the directrix, and you'd be right. Notice the focus is at 0, 3, and the directrix is the line y equals -3. It goes through the point 0, -3, and the origin's halfway between. So if that's true for this point, is it also true for other points on the parabola? So let's put a point on our parabola. Okay, let's say we go right there. And we want to know, is this distance the same as the distance to the directrix? So let's do a segment to take the distance from there to there. Notice it's this value g, which is about 3.68 right now, and that will change as we move it around. Okay, so notice it's not a circle, right? That distance doesn't stay the same, otherwise it'd be a circle. It changes, but let's put it right about there. Now, how far is this point from the directrix? And then we have to remember something from geometry. When we measure the distance from a point to a line, we have to take that shortest possible route, which is the length of the perpendicular segment. So what I'm going to do, and just one more stay, I can't just pick any point to go to, right? I've got to pick the closest point, the point that's perpendicular. So what I'm going to do is I'm going to choose my perpendicular line tool. I'll click on the directrix. I'll click on this point. Now I've created that distance that I'm interested in. Now to make this a little bit easier for us to see and to reduce this a little bit, I'm going to put a point there. I'm going to hide that perpendicular line, and I'm going to put a new segment from there to there, which GeoGebra is calling I. So what do we notice about G and I? Are they the same length? Well, when I look over here, G is 4.13, and what's I? I is also 4.13. Is that stay the same when I move it? G right now, 6.41. I is 6.41. This point is the same distance from the directrix as it is from the focus. And if you want to really see that, I think a circle is a great way to show that two things are equidistant. Take a look at that. Okay. Wherever I am, that circle goes through the focus and that point on the directrix that it corresponds to. So that's that major relationship that we have with the parabola that's new to us, that we didn't see before when we spent all the time on the quadratics. Now, there's a couple other things that I want to show you here. Let's delete this perpendicular segment for a moment. Now, remember when we talk about an ellipse, there was a reflection property that happened where we said, you know, if we took something from one focus, shot it out, it reflected off the ellipse, it would go to the other focus. Well, here's what I want you to notice now. I'm going to, like I did with the ellipse, is I'm going to make a tangent line here to my parabola at that point. And I am going to reflect, where's my reflection tool? There it is, reflect this point, or that segment about this line. And notice it is that perpendicular segment. It's the same one, isn't it? Okay, so that's kind of neat that these two segments are reflections of each other. Very cool. Okay. Now, what else? Well, remember, let's see here. No, I want that. Let's delete some other stuff. Let's delete this now. Okay. Let's bring that perpendicular line back in. Still on the delete tool, so I guess I deleted my perpendicular line. That wasn't good. Let's create a new one. Perpendicular line tool. There it is. What happens if I take some sort of signal and send it in to the parabola and it reflects off the parabola? Where does it go? So now let's reflect this perpendicular line over that tangent line, so it's reflecting off the parabola. So I'm going to choose this perpendicular line, I'm going to choose the tangent line, and where does it reflect? It goes to the focus. And this is a major concept that's used in quite a few places. You've probably seen this in satellite dishes, right? Where you have a satellite dish which is parabola shaped. There is something in the center, a receiver, okay, that comes up. That receiver is located at the focus, because when a signal comes in, it reflects off the parabola and it goes to the focus. So wherever that signal comes in, okay, if it's over here, comes in, reflects, goes to the focus. It's over here, comes in, reflects, goes to the focus. So that's pretty cool. Another reverse application of this is we can send signals out from the focus out in a particular direction. So satellites that send signals, or possibly things like lamps, headlights. Okay, have you noticed that headlights or lamps can kind of sometimes be parabol shaped, but three-dimensionally? The light takes off, is shown from the focus, so it leaves the parabola. But then any light that comes not in the direction we're shining, but back into the lamp, reflects off the mirror that's on the back side of the lamp, and it shoots it out and forward. So those are some key features I wanted to show you in the parabola. We've got a focus and we have a directrix. I'm going to let, like I said, somebody else do the rest of the teaching for you. Good luck. Thanks for watching.